When they collided with the ancient Earth, comets helped fill our oceans. But it's also possible that they delivered something else. Are comets also the bringers of life?
As far as we can tell, the early Earth was mostly a hot, dead rock. And yet here we are, this wonderful, rich environment of life. Well, where did that come from? What actually brought the building blocks of life to the Earth?
These impacts may have been a key stage in the formation of life by fusing amino acids together to form proteins.
These complex molecules can survive that collision. And not only that, simple organic molecules can be cooked into even more complex molecules. So comets can bring the seeds and the fertilizer of life to spread across a planet.
There are trillions of comets in our solar system. If each of these has the ability to seed a planet, then it's likely that we are not alone.
If life here is somehow related to comets bringing these wonderful rich organics here, it very well may have happened elsewhere in the solar system as well.
Comets may be seeding life all over the cosmos. "60 light-years away from the Sun, far beyond the Kuiper Belt and the Oort cloud, astronomers have spotted a huge band of comet dust wrapped around a young star called Eta Corvi. The dust could be evidence that comets are raining down on the planets orbiting this star. They might be seeding life on this alien world at this very moment. But what if comets could spread more than the building blocks of life across the cosmos? What if they could also deliver living organisms? June 1996. NASA's Galileo spacecraft is 6 months into its exploration of the Jupiter system. As it passes Jupiter, its electronic gaze turns to one of the gas giant's ice-covered moons, Ganymede. The probe's magnetic readings reveal something totally unexpected.
An entire world covered with ice, but underneath that ice, an ocean.
That ocean contains more water than the Pacific, despite the fact that Ganymede is smaller than the Earth.
The discovery raises excitement among scientists worldwide.
Whenever you discover water on another planet, the first thing you think of is life.
How could there not be extensive life in that big ocean?
But if life exists in the depths of Ganymede's seas, it faces many challenges.
Ganymede has oceans, but they're not like the oceans on Earth.
Perhaps the greatest challenge life there would face is the thick ice that covers the water.
Ganymede's a different world. If we imagine the habitat on Ganymede, it's going to be a thick layer of ice. Too much ice at the top for sunlight to get down.
Pitch black, there's no sunlight. It's freezing cold and there's no oxygen. How can life possibly thrive?
For nearly 20 years after the Galileo probe's first scans, scientists believe Ganymede cannot support life.
To have life, you really want rocks and water together, because they produce the elements that living things need.
Where you want to look for life is going to be in that last ocean level because it's in contact with rock. So if we're looking for life on Ganymede, we're going all the way to the bottom.
With all the elements necessary for life present, there is good reason to hope that the ice water of Ganymede could be home to more than just microbes.
We could go to Ganymede expecting only simple life, but I think we should keep our eyes open just in case there's something more interesting as well.
It's had 4.5 billion years to evolve. There could be long, ribbon-like creatures, 30 meters long, 2 meters wide, moving across the bottom, predators coming right up behind him, sensing these trails moving, and snap.
Whatever form life takes on Ganymede, we could encounter it within the next decade.
So the next step is the JUICE mission, which is specifically designed to go and study those oceans of the icy moons of Jupiter.
The truth is, there could be no limit to the life that lives on Ganymede. It's really up to us to go investigate and find out.
November 28, 1967, Cambridge, England. Jocelyn Bell is an astronomy student examining radio wave data from the most sensitive telescope of its kind.
Jocelyn Bell is looking for quasars, objects that are 100 times brighter than the Milky Way.
She analyzes the 100 feet of radio wave data generated every night.
And it's just all on chart paper. I mean, miles and miles of chart paper. That's the way they did it back then. And she's going through and looking for, radio sources.
What they're expecting to see is radio emission in continuous but somewhat random bursts.
Instead, something else grabs her attention. It's a regular pulse.
What she sees is a signal spaced precisely 1 1/3 seconds apart.
It's very regular, like a clock, better than any clock, in fact, that we could build.
This is beyond weird.
Bell shares the data with her supervisor, Anthony Hewish. The mysterious, repetitive pulse is like nothing he's seen before. But he does notice a pattern.
The pulses are so precise, they cannot be coming from any natural phenomena. So it makes sense to ask, is this from man-made interference? The most likely source would be their own equipment.
To rule out equipment failure, Hewish asks another telescope team to see if they can detect the pulse.
And they find the same signal. So it rules out man-made interference.
The only answer was, it was actually coming from outer space.
Bell suggests a controversial explanation.
She calls it a signal from little green men, LGM. It's so unnatural, it's almost like it could be from aliens deliberately trying to send us a signal.